Encentric material. It is applied to any semiconductor material that has been carefully refined to reduce the number of impurities. Negative temperature coefficient. It is a material that experiences a decrease of their electrical resistance when its temperature is being raised. So the lower the coefficient, the greater its decrease of their electrical resistance. Covalent bonding. It is the bonding of atoms, strengthened by the sharing of electrons. So what is an N-type and P-type semiconductor? So here we have an example of a P-type semiconductor. So semiconductor can be created by adding its impurities, which is trivalent impurity. So this is an example of trivalent. So once the impurity is added, then it creates a hole here, a hole or vacancies. Then this atom is called an acceptor atom. Here below, is it's describe the carries of the p-type semiconductor. Its majority carries is the hole or vacancy, and its minority is the charged atom here. So while in p and n-type atom, it it can be formed by adding the impurities of pentavalent. So this is an example of pentavalent. So once the impurities is added, it gives an extra electrons or free electrons, and it is called a donor atom. Here below is its carries, which is majority carries are the charged atom or the charged atom, and while the minority is the hole here. So energy gaps of the insulator, conductor, and the semiconductor. So here in the chart, we have a valence band, the gap, and the conductor band. So what is the valence band? Valence band is where the valence electron stays, and when the electrons gain some energy, then it starts to leave in the valence band and start to cross in the gap. And when it reaches in the conductor band, then that is the time when the conduction happens of the materials. So insulator, which is current does not allow to flow or does not flow easily because it has a large gap, and example are plastics, woods, or any material that energy cannot flow. So in order to flow in the conductor band, we have to uh, it needs a lot of energy or current flow to reach the in order to have a conduction process. So while in conductor, which is the current flow easily because as you can see, there is no gap or almost have a no gap. So current, even if we the current is just a even if the current having a small amount, it will flow easily because it has no gap at all. So example are metals, which is iron, copper, or etc. Semiconductor material has the property of conducting between the conductor and insulator. So it means that it does not allow current to flow just as conductor, as well as it doesn't block current like insulator. So even though this is a semiconductor, um, it has a chance to conduct a current or block a current because it has just a small gap here. This illustration. This is the gap. So now we will explain what happens in p-n junction. So here in the illustration below, we have the P region and the N region. And in the middle, it is called a PN junction. So this is the basic silicon structure of PN junction. So this 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 chart is showing the minority and majority carriers. So free electron starts to diffuse beside in the PN junction, which is then it will cross the junction and fall in the hole of beside the junction of the P region. So here in the next illustration, this is called a depletion region where positive and negative charge are positive and negative charge are being created. It is because of the diffusion of the charges carriers. So for every free electrons diffuses and crosses into the junction of the P region, then falls in the hole. It then leaves a positive charge in the N region, here N region, as well as in the P I mean P region. It creates a negative charge. In no bias situation, there is no external voltage is applied. So the absence of voltage is the absence of voltage across the resistor is resulting in zero current. While in reverse bias, it is an external potential of volts is applied across the PN junction, such the positive terminal is connected to the N-type material and the negative terminal is connected to the P-type material. The number of uncovered positive ions in the depletion region of the N-type material will increase due to the large number of free electrons drawn to the positive potential in the applied voltage. And the forward bias is condition is established by applying the positive potential to the P-type material and the negative potential to the N-type material. The application of a forward bias potential VD will pressure electrons in the N-type material and holes in the P-type material to recombine with the ions near the boundary and reduce the width of the depletion region.